Yeah. Am I audible?
Yes, yes, you are.
Yeah, Syam, can you go to the first slide and then present it in presentation mode? Yeah. Yeah. Good morning and warm welcome to all. Thanks for joining this session, even during your busy weekend schedule on a Saturday. It shows how interested you people are. We hope you will be benefited by some means from this session. First of all, I would like to take a moment to thank Prathidhwani to conduct this session and allowing us to present here. Syam, next slide. Previous. Yeah, correct. Here we go. This is the HNABlock team who will be the presenters for the day. Let me give a brief introduction of the team. Myself, Sunilkumar, Elavakkunnath, enterprise architect from HNABlock Trivandrum. I have 17 plus years of experience in the embedded, mobile, middleware, DevOps, and cloud technologies. You can call me simply Sunil. Next, Syam Sasipillai, in short, Syam, who is the associate cloud architect in HNABlock with 11 plus years of experience in the administration, migration, scripting, DevOps, and cloud areas. A real experienced and reachable guy. Here goes Midhun Madhusoodhanan, who is an associate architect from HNABlock with 13 plus years of IT experience in the field of middleware, data, DevOps, and cloud technologies. Yeah, Syam, you can go to next. This will be the agenda for today's session. You will see the traditional approach by which cloud infrastructure can be provisioned and its drawbacks. Then the basic concepts of infrastructure as a code. In short, we call it as IaC. Then details on Terraform, which is one of the market-leading IaC framework, where you will see the Terraform process flow and various commands being used over there. Later, we will take you through the environment setup for Terraform, and you will see different Terraform files and their details. Then a short demo on creating cloud resources in the Microsoft Azure environment and how we can update an existing environment while maintaining the resource states. We will also show how a higher environment can be spun up with minimal changes. We parked a slot to give a quick introduction of the advanced version of Terraform, Terraform Enterprise, or TFE in short. The end of the session is parked for the questions from the audience. We know you might have queries when the session is in progress. However, we would request all of you to note those questions down and park them for the Q&A session. I personally, on the previous slide itself, I personally think the basic understanding of any cloud environment and concepts would be helpful to get more out of this session. However, we hope this session would be fruitful to all here. I would say all of you will have a basic understanding of Terraform and how to use the Terraform to create and manage cloud infrastructure resources as a takeaway from this session. Syam, next slide. Yeah, let us begin. This is how we traditionally created and managed cloud infrastructure resources. As you see in the diagram, application team will provide infrastructure requirement to the cloud team. Cloud team would analyze the requirements and would do the manual steps in the provider portal to create the first environment, say the development environment, as we see in the diagram. Then same manual steps will be performed to create higher environments. In here, the higher environments are QA and prod. As you can see there, the different environments and their resource states exist as silos. They do not have any common connection between the configurations. Any similarities or differences are residing in the minds of the cloud engineers who involved in this process. Also, if we need to make any update, say change existing resource, add a new resource, or delete a resource, this will also be manual inside a given environment, or even that would be the same for higher environments as well. Now note, we are in need of propagating these changes to higher environment. I already covered that. This will also be manual. Normally, all of us know we will have different cloud engineers working on different environments. So this will add to the complexity because we need to depend on different individuals. Syam, next slide. Now, let us see the downside of the traditional way of manual provisioning of cloud infrastructure via portals. We already saw we have to rely extremely on individuals from cloud team in the traditional approach. As we know, any manual interaction or processes will lead to errors and issues. Also, it is difficult to maintain and update configuration document per environment, as the configuration can change in time, and the necessity of manually update the document would be really tiresome. Enterprises need to have streamlined and complex processes in place to manage and monitor manual cloud activities. To make sure that these changes or any changes are tracked and implemented in time as per the requirement from the projects and teams. Also, I'm actually going through the difficulties or downsides of the traditional approach. So it is very difficult to track the progress of an incomplete deployment process. Suppose a cloud engineer stopped a cloud deployment halfway through, and another cloud engineer need to resume the process. Here, lot of manual interaction between two of these members would be necessary. Or what they have to do, they have to manually verify the installation status from the portal or portal logs to know where the last person stopped. And all these manual steps would be necessary to resume the installation process. Another point to note is that it would be very difficult to get the state of the cloud resource deployed in an environment. Means there is no single point where we can refer to get all the changes. Once it is done, it is done. We have to manually go there and verify whether the changes are there, what we have to do next, and sort of things. There is no central point of. Now, if we need to maintain a configuration consistency between different environments in a system, it would be real difficult as well, because we have to maintain that separately somewhere on documentation, and engineers have to follow that one by one. So these are some of the difficulties in traditional approach. Yeah, you can go to the next slide, Syam. Yeah. We saw how difficult the traditional way was, and now let us see how infrastructure as a code works. As the name implies, right? It is a way of managing and provisioning infrastructure via code, and this is also with no or very minimal manual effort. Avoiding or reducing manual efforts brings below benefits to the IaC platforms. It is the efficient way to manage cloud resources, as the current configuration details are readily available in code, and it is easy to maintain and deal with. This boosts the productivity of the teams. As we already discussed, reduced manual efforts will reduce the errors or issues in the system. Since we use configurations for different environments, since we use the same code configurations for different environments, it would be really easy and fast to spin up additional environments. This reduces engineering efforts and thus saving cost. Another great factor for developers are that most IaC platforms currently available in market supports unit testing of the code that they write. This also helps in reducing errors. Most of the IaC platforms has self-explanatory and human-readable scripts for better understanding. This factor would help learn the platform easily and adapt to it. As you can see here, right? Some of the lead in the right, some of the leading IaC platforms currently available in market. Primary one being Terraform from Hashicorp, AWS CloudFormation from Amazon, Google's Cloud Deployment Manager, and Microsoft's Azure Resource Manager. Now, now I would request Midhun to take us through the specifics and details of Terraform framework from now onwards. Midhun.
Yeah, am I audible? Thanks, Sunil.
Yeah.
Yeah, okay. So as we discussed, we have a traditional approach, and that's the way how we actually do the cloud provisioning. So let's come and see what is in the Terraform. So Terraform is basically an open source IaC platform developed by Hashicorp. It's being 8 years. It is there in the market, so it have a great legacy to say, and it is the tool developed using Go, and the declarative approach is the approach we are taking. The Terraform is actually using. So in this method, we only define the desired state, and the tool is able to understand the configuration what we have and deploy the changes to the target providers. And for the easiness of development, the Terraform has developed a HCL, what we call Hashicorp configuration language, which makes things more easy to configure or script a particular resource and do a basic set of programming logic inside that script. And the key benefit of this language is it is easy to understand, and as I said, it is having only basics of programming language, so that we can make some conditions on it for a particular environment and we can target for it. So that's a key benefit of HCL, and it is human readable and installable dependency plugins. So the Hashicorp have portal, and it have the different set of packages where all the dependency will be loaded there, and while we are doing the provisioning, it will automatically download the dependencies based on the resources what we are deploying, and it will do it automatically. And the Terraform unique feature is the state file, where it keeps a single point of track where all the resources being provisioned using Terraform. So there is a key unique thing there in the Terraform respective of others. Um, so another thing is it is possible to manage different configuration. Let's say if we have a QA and the dev is having some difference in it, that is also possible to manage using the programming language in it. And the great thing the Terraform offers is it support the multi-cloud, the cloud legends like AWS, Azure, and GDP, and a lot of cloud providers. The Terraform supports it. Okay. So let's see what is there in Terraform and what is when we do an action on it. So let's consider the phases. As Sunil said, in the traditional approach itself, we will be having a list of resources, and the team will be providing those items. So the engineer will be identifying those resources and generate script for that particular resource, and those infra code will be placed somewhere, and the Terraform will be continuing its action starting from init. Init is the place. Init is or command or an action or a phase, we can consider that, and in that phase all the dependencies for that particular resource will be downloaded, and it is provided by the Terraform itself. And planning is the next stage, where the Terraform will be considering the list of resources, what we call the desired state, and it will be having those items in one side, and in another side it will be having a state file where it keeps all the status of a particular deployment, and another end is the cloud provider. So all these three things will be considered, and the engineer will be getting an insight to the plan. The Terraform will supply a plan. In that plan itself, we will be able to understand what all are the changes we are going to deploy in this current execution. And apply is the phase where the engineer will be granting the uh, permission for the Terraform to apply the desired changes to the cloud environment. And in the right side, we have the providers and the resources. So once that is applied, the cloud provider will be having all those set of resources there, and we can verify it in their portal itself. That is altogether the Terraform actions. And as I mentioned, these are all the Terraform commands what we have. The init is actually preparing the execution for each and every commands. We need to first run the init so that the Terraform will be able to understand what is happening there, and it will be downloading all the dependencies on it and create a working environment for it. Validate is the next task, where we can validate our script, what we have we have written, and it will be validated against the requirement or the against the statement or requirement, and we can do that validation steps. In these steps, we will be able to identify whether we have created any errors in our scripting. And next, we can have the planning. As I mentioned, the planning stage, we will be comparing all those resources with the state file, and we will be moving forward. And apply is the command where we actually do the action, where create or update on our existing infrastructure based on the current desired state. And destroy is the command we will use to tear down the entire thing what we have created using Terraform. So moving to the next slide, let's see what will be the actions we will be follow and how we can actually set up an environment for Terraform. For setting up Terraform, we need to download the Terraform installable from the link have given, and it is available for Windows, Linux, and Mac, and different set of OS. So based on the machine what we are running the Terraform, we can download the respective packages from it. In this example, we are covering the Azure. So we basically need an Azure CLI installation in our machine. So that's the link is provided there. And for the demo purpose, we are using Visual Studio ID and the Terraform plugin in it. And also there are other providers just ID like JetBean and Eclipse. There are also Terraform plugins are available. A developer can leverage those plugins and understand the language more easily. The scripting kind of stuff. And this demo purpose, what we have done is we have created an Azure free account, which will be having a 30-day trial or a $20 amount or whatever, which come maximum, it will be. What come first, it will be eliminated. Yeah. Now let us see, let us familiar with the Terraform files and standards. So let's come to the first file. So before going to the files thing, all these files are just a naming convention. We can give whatever the name we have, but the content need to be there. The Terraform tool is intelligent enough to understand what is the tag and where to start. That's just we are keeping a standard on it. So let's see what is there in the main.tf file. Usually the Terraform file, all the file will be having a .tf extension. So just keep in mind that main.tf is one of the file, which is basically a configuration file, which have the provider information at its version. So right side is a code snippet for it. Basically what here we are doing is creating a resource group, and above is the mention section. We can see the Terraform and its version and the required provider to be downloaded for our current execution, that is Hashicorp Azure RM. So that is the packages while executing that init operation itself, it will be downloading it. We can see that in action in our demo itself. Moving to next one. Now the variable declaration file. This is the file we usually place all the variables in a single file. Variable is those files or the field which is changing for each and every environment. So Terraform gives an option to declare variables in different data types, following other data types for it. So whenever we need to change a particular variable for based on a environment or any other criteria, we can declare a variable and use that variable for the resource provisioning in the resource file script. Moving to locals.tf or local variables. So in few cases, we will be having repetitive words or repetitive variables to be used across all the script. In that the case, we will be using locals, where we can actually have the provision to get construct another field with the input or the variable what we have, and do and copy that script to all other expressions. Basically, it will be avoiding the repetition and complex expressions. So another variable is an environmental specific variable, what we call auto.tfvar variable. Basically, it is an assignment, or the variable what we have created already. We can assign value to it. Terraform will automatically detect those files while the execution itself. This is given to assign a value which is purely environmental specific. So right side is the code snippet for it. So another variable is an output variable. Usually it can be considered as a return value in a programming world, and it is for exposing those values which we are interested to the in other modules or console. So if we want to display something back or revert back something, we can use the output variable. And right side shown is the syntax for it. This is a resource file where we actually create a particular resource for the cloud, targeting a cloud. And it will be always having an extension of .tf, and it's basically contain a declaration for the cloud configurations. And Terraform registry name will be there after the token resource. You can write in the right side, you can see the script. It is starting with resource tag and that resource token. And after that, there is a Azure RM Windows virtual machine. That is the module registry, which will be available in the Terraform. And after that, there is a tag, what we call the resource tag, or this tag will be used for getting or setting some values in that particular resource for our next resources or dependent resources. For that purpose, we are creating this tag. And you can right away see that all the resources will be having parameters and sections which will give a developer an idea about what is the main section we are going to, just like in the right side, the OS disk. So basically a person or a developer will be able to understand that. So that section will cover all the operating system disk and the properties in it. So it is simple and easy to understand, and the entire resource script file is structured in such a way that it can be easily understandable and more readable. And few of the fields are seems to be mandatory. It is purely based on the resource. Based on the resource, few field will be optional too. So mandatory fields need to be, we need to give those mandatory field for a mandatory, and optional fields we can do whatever the value we require. Another key identifier for this Terraform is the state file. Right side shown is the template for it. Terraform state file is encoded in JSON. It basically contains the metadata of the cloud resources by Terraform. All the resources which is managed by the Terraform will be, the state of that particular resources will be managed on this state. And this is an important file. And it will be updated or managed on each and every run by the Terraform itself. While in cloud environment, we can keep this file in local setup or a remote storage. Both option is available for the from the Terraform. So I'm slowly moving to the demo. Over to Syam. Thank you.
Thank you, Midhun. So in the demo purpose, we will go through a real-time example for a requirement, for a project requirement. As a scenario, in my project, I need to have a dev environment and a QA. That means I need to have multiple staging environments, and how we can create this through a Terraform script. So in the demo, first of all, I will start with creating a resource group with a single VM. And next stage, I will create one another VM in the same resource group and verifying what are the changes that Terraform will show to the existing resources. Like, will it delete the existing resource, or will it change any parameters of existing resource, or it will create another resource without touching the existing infrastructure. And the second stage, I will create a new environment called it as QA or prod. That means another environment for my project with the same consistency in the configuration. That means same configuration of these two VMs will be cloned or image to here to create the next set of environment. So from here, we can continue creating deployments of prod or LNP. That means another environment we can create from the same code snippet. And before going to the deployment session, first of all, we will go through the local environment setup and source code explanation. So yeah, for local environment setup, first of all, we need to download the Terraform. So as Midhun mentioned, Terraform is available for various OS flavors, Windows, Linux, Mac, FreeBDS, OpenBDS, Solaris are supported by Terraform, and we can download it from this Terraform download site. This is also included in the link. And second, for the demo purpose, I am using Azure as the provider. So installing Azure or installing Azure CLI is mandatory for connecting and getting authenticated for the Terraform code to run in Azure. So we need to download the Azure CLI from Microsoft site. This link is also provided in the appendix. And the IDE I am using VS Code, Visual Studio Code as the IDE, and I'm using the Visual Studio Code terminal for running all these commands for Terraform as well as Azure CLI connections. And second thing is we will go through the folder structure and Terraform files. As Midhun mentioned, there are multiple kind of extensions available for Terraform, and we will go through each extension like TFRs, TF state file. So what are the things or what are the use cases of these files in the Terraform execution? First of all, main.tf, it will have all the provider information. Since I'm connecting with Azure RM will be mentioned as the provider name, and we can mention the version details of Azure in the main.tf file. Next important files are the .tf extension file, which is resource. We are creating multiple resources or dependency resources for creating a virtual machine. So these are the resource related files, which is numbered from 01 to 06. These files will be useful for creating virtual machine and its dependency resource like network interface card, subnet, virtual network, as well as a resource group to place all these. It's a container. Resource group is basically a container for placing all these resources inside that container. So next, Terraform state file. It basically, we can say a blueprint or metadata of what is the current state of deployment in the current directory. And last, variable.tf. Here we are mentioning all the variable related variable. Here we declare all the variables. So example, in my code main.tf, I am declaring a couple of variables to get parameter value from the variable. So these variable will be declared in the variable.tf file. As an example, you can see here I given application name as HRV and the same variable file here. Here the variable result will be look like concatenation of two strings. One is var.application name and another is var.environment. So these two strings will be concatenated along with a string called RSG. So the resource group name will be application name plus environment name plus RSG. This will be the resource group name as per the Terraform configuration. So these all are about the folder structure as well as the file, what are the file doing in the Terraform. So going into the action, first of all, I need to connect the Azure. So AZ CLI I already installed. So I'm running the Azure CLI command and going through the authentication process. So it's successfully logged in, and in the terminal, I can see that my Azure account is logged in with the authentication, the given authentication. Next, we are going through the Terraform deployment. So first of all, we will run the Terraform init command. This will be the first command we need to given for initializing the Terraform script. Initializing the Terraform script, and it will download all the dependencies for running the Terraform files. So it's almost like Git init. Those who are working with Git, they can understand the first command will be Git init. So Terraform init will also do the same task. That means downloading the dependency for performing the Terraform actions. And second command will be Terraform Plan. So Terraform Plan, the command actually preview the things what we are going to do in the cloud environment, or what are the things going to happen. It will show a preview or a dry run result, but it will not get affected in the environment. So here we can see 7 resources will get added in the environment, 0 changes and 0 destroy. That means with respect to our declared Terraform code, 7 resources will be created, and there is no change to existing resources, and 0 to destroy. I will go through the Terraform plan once again. Before that, I'm typing another command, Terraform apply, and this is for applying the Terraform code or deploying the Terraform code. This will be the last command from the Terraform. So coming to the previous command, Terraform plan, actually it will say, it will tell us that what are the things it is going to deploy, or what are the things it will going to change in the cloud environment. You can see it's creating a virtual machine with the parameter we given in the slide in the configuration files. Also, it will create the resource group. Its dependency resources will also create. And when we are running the Terraform plan, it will show the entire string or entire variable get concatenated. You can see its var application name, var environment, and RSG. It's concatenated with the result HRB TRV DV RSG. That means HRB TRV is the application name, and when we are seeing the environment variable, I declared as DV. So DV will be the DV stands for development, and which is concatenated with the another variable. It's called application name. And last, RSG. So Terraform plan will show the details of what are the things it is going to apply or going to happen in the environment. So
yeah, one point to add over here is in the environment, the variable file, right? The variable file actually we have declared and provided a default value of DV. So it is like declaration and initialization at this on the one go. So that is why we do not have a variable file over here. Normally, variable in the variable files we'll be declaring the thing and we'll be having it. So like Syam will be mentioning that at a later time, but just thought of mentioning that. And also while going through the plan, right, there is a convention. Like if it is a plus, green plus, it would be like an addition. The new resource will be created, like the symbols that you're seeing, or the like Terraform will show us the plus is create, and a yellow tilde will be an update, and minus like a red minus will be delete. So we'll be able to see what is going to happen to the resources if I am applying these changes. So even before doing any changes, we'll be able to see what is going to happen. Yeah. Thanks, yeah.
Yep. Thanks, Sunil. So the next command, I run Terraform apply. Terraform apply basically do, once again, it will do the Terraform plan result you can see here. And it's asking for a confirmation that if it is desired, the changes are desired, then we can confirm that yes, yes, we know the changes, and it's good to deploy in the Azure portal. So I given a value yes, so it started to deploy in the Azure. As Sunil mentioned, if we are seeing any changes or destroy in the Terraform plan, then it is better to review once again that it is decided to do a change or do a destroy in your environment. Review once again, and if it is a decided one, go ahead and do yes, a confirmation as yes. Otherwise, please cancel this plan or type no. So it started creating in the Azure. So we can see the verbose details. Azure resource group is getting created. Public AP started creating. Network interface is also creating, and all those verbose details are printing in the terminal. So now we are going to the Azure Cloud, where I can see a resource group created as per the plan. A resource group is created, and the resources are starting populated according to the desired Terraform code. So first VM is created with its dependency resources, and so a virtual network and public AP is also attached. When I am browsing the public AP, it's getting deployed. Let it get deployed first.
Yeah. Have we mentioned about the code being pulled from Git? Yeah.
Yes, I will go through once it is completed.
Yeah.
So in the virtual machine, when we are creating a virtual machine, we created an extension for the virtual machine. That means virtual machine extension basically used for post provisioning. That means after completion of OS deployment, say an example, we need to install Apache or IAS need to be enabled. So, and any custom script, if you want to, like domain joining script need to run, it might be pulling from Git or somewhere else. We can code those details. That means post provisioning details we can mention in the Terraform virtual machine extension file. Here I am going to download a index.html and enabling an Apache mission, Apache website inside a Ubuntu server. So you can see the same IP address showing a index, or pulled the index.html from my GitHub. This is the GitHub I configured for that demo, and website is up and running with respect to the code I written in the Terraform. So the entire website of my project deployed within 5 to 10 minutes, almost not even 5 to 10 minutes, 1.10 seconds. Sorry, 1 minute and 10 seconds. Within this time, my website or business is up and running in the cloud, and my users can able to easily access from the, once we map the DNS, it can be able to use from external user through the DNS name. So in the next stage, I'm going to create one more resource, one more Azure VM by simply changing the count. So I started deploying one server. Now I am going to deploy the second server, and I'm going to the same init. It's not mandatory to init once again if we are running the same resource, and plan. We can plan the code once again. Otherwise, we can directly apply. Since apply consists of plan and apply, we can directly go with apply. Sorry, post-COVID effect. Yeah. So if we are changing the count of servers, then it's showing that resource group is already created and VNet is created. Instead of creating 7 resources again, it's saying that only 4 resources need to be added for the second run, for only creating the second resource. So I'm good with the plan. So
like in this case, actually, it will be creating one virtual machine, an NIC, one public IP, and an OS disk. Those are the 4 resources. I think we can go through that. Yeah, Syam will be taking us through that. Yeah, once he going through the plan. Yeah.
So in the current scenario, you can see only one VM inside HRV, TRV, DV resource group. In the development resource group, we can see only single VM. So my requirement is increased. That means traffic got increased in my business, and I would like to implement one more or balance the load. I would like to implement one more server with the same code. That means with minimal change, we can deploy a new resource. So it's asking for the confirmation. We need to review the code once again, or review the plan once again. And if it is desired change, that means it will create a network interface card with the parameter we given, and public IP. It will create a new public IP, and it will create another VM with index 1. And these are the parameters. It will get deployed in the Azure portal. And one storage disk for we can say it as C drive or OS disk. And with virtual machine extension, that means it again pull the index.html on the second machine. That means the deployment of our website to the second machine will also take care by the Terraform extension. So the second public IP is added to the Azure resource group. Yeah, second VM is started to get deploying in the Azure. So this is a public IP attached with the second VM. Let it complete the extension. So now it's creating the extension file or running the extension file in the same VM. So with minimal code change, I can able to create multiple servers. In normal scenario or traditional scenario, we can see creating a virtual machine. So I need to create a virtual machine in cloud. I need to give all the parameters from basic. I need to select the resource group, virtual machine name, region. All these details I need to fill along with other parameters, disk parameters, networking parameters, management. All these things we need to install or manually enter, or these values need to be populated for creating a virtual machine. So think a scenario in my project, in my new project, I can create a one VM. My requirement is if we need to create 10 VMs, then this step need to be repeated 10 times, or 10 engineers need to be engaged for this. So instead of wasting that manpower, or instead of doing more manual effort on creating virtual machine, we can rely on Terraform, and it will easily create by doing this configuration changes or creating a Terraform file. It will create multiple resources according to the Terraform configuration file. So now my dev environment is completed. You can see my dev environment is completed with 2 virtual machine, and the second IP address, yeah, the code is again pulled from the Git repository and it got deployed. So one is with 63, one second IP will be 20. So these 2 VMs I can connect it to an application gateway or load balancer to balance the load. So it's pretty simple for spinning up an environment with minimal effort. So it took 1 minute and 10 seconds to spin up my second VM. That means now the traffic is handling by both the VMs, and my business is again up and running in the cloud. So the dev environment setup is completed. Now my requirement is to create a QA environment for the same project. So here itself I am cloning. I'm cloning the same code. You can do it through just want to show the hierarchy folder structure. That's why I am doing it from here. I can do through the VS Code itself. So the second QA environment, I clone everything from dev and just removing the dev related files. So
and log file as well.
Yeah, removing.
Okay.
So the same code, when we started deploying the development, same code we just cloned to QA and only changing the minimal variable, like from DV, I need to create a QA environment. Nothing changed, nothing going to get created. Here I am straight away creating 2 virtual machine, which is almost same as like the dev environment. So we started with Terraform Init.
No, change it to QA, change it.
Yeah, sorry. So Init will again pull the dependency file for running the Terraform resources in the QA environment. So it's pulling the details. So you can see these are the files it get downloaded according to the Terraform resource. It's almost like Git init. Git init will also add a extension file, .git extension file. Terraform will also create a dependency packages inside that hidden file. So second command will be Terraform. I'm directly going with apply.
Because it does contain plan and then apply. So yeah.
Yes.
And for this scenario, since plan apply is running, so for this demo, actually we went with a very simple architecture to showcase how we can simply spin up a stage, and then on top of that you can add any resources without affecting the current state of the stage, and easily spin up an environment. And as Syam was rightly pointing out, if we need to have load balancing capabilities added to this thing, we can go for load balancers or gateways or anything like that. But we have not gone to that extent, just to showcase how simple it is to spin up a resource and work with it in any provider with using Terraform. Yeah.
Yeah. We can see the Terraform Plan result. You can see the plan result. It is showing 11 resource. Previously it was 7 because of we only did 1 VM deployment. Now we are doing 2 VM deployment and it's dependency resources. So 11 resource will get added, 0 change and 0 destroy. We can go through it is almost same as like dev. Only change is the name will get changed to QA. So remaining all the configuration will be consistent for QA and dev, or if you are creating an LNP or prod, it will be consistent for all these environment. So it's taking in action. So it started to create a resource group, new resource group, because of it's not touching to the existing resource group, which we created for the dev. You can see in plan itself, there is no destroy. And all the resources are getting deployed in the cloud environment. If you can see, the second resource group with name QA only changes. First resource group is dev and second resource group is QA. And all the resource group will be created with an extension of QA. And here in the dev, you can see all the resources is created with dev, DV notation. So from here itself, if you are working in a larger environment, you can able to easily identify the resource which is development or QA if you are following the naming convention, or which is represented for any particular application. We can also see from here. So if you are enforcing this policy in our organization, we can able to easily identify the resources even though we have multiple environment or multiple projects in the same Azure cloud.
Yeah, Syam, we have a question from Sunil Nair. Like we can park it for the lab, but since the plan apply is running, I can answer that. So Sunil, actually, the initial in the initial plan, we created 7 resources, and in the second stage, actually, it was 4: VM, network interface card, OS disk, and a public IP. 4 resources. So 7 plus 4, 11. I think that is clear, right? Am I audible, Sunil?
Yeah, you are audible. Thanks.
Yeah,
So
but-
what I thought was that you are only counting the VMs.
Yeah, no, not. No, it's like all the resources. Yeah, all the
Okay.
resources.
Okay.
Yeah.
All the dependency resources will be included as resources. So you can see that's why I mentioned 1, 2, 3, 4, 5, 6 in the numbering. I mentioned for each resources. So these all are calculated, or these are considered as resource. You can see the resource itself in the Terraform. You can see the syntax of Terraform is like a resource starting with a resource notation, then the type of resource, then a tagging. Tagging is basically when we are calling it from calling the entire block from outside this block, we can use this tagging, and it is very useful in a complex architecture for identifying this resource group block, group or any other resource block.
Yeah, just to be simple, like we created a Azure resource group and named it RG. And if we need to use this resource group in any other modules, we can use that tag or that name RG over there.
Right.
And in this case, one point to add, Syam, like in this case, actually, we just change the variable DV to QA to create a QA environment. Maybe for higher environments, it might not be the case, like LNP and prod, there might be having higher resource requirements. We can make the changes to the variable files accordingly to create OS disk and all those according to our needs. Based like the tires and all those things, we can change it. And this is just to showcase how we can create the thing. So we can make specific changes to different environments based on our need.
Yep.
Yeah.
For once again, clarification on your question. First 7 resource is this stage. On the first stage, we created only a single VM, and the resources of resource group and VNet is already created in the first run itself. So second run will not create any new resource group or a VNet. So here we need to have 7 new resource to get added. Here we only have 4 resources to get added.
Only thing to add is that actually the OS disk is not represented in this diagram. So that one you have to add that one count.
Yeah, I missed that.
That's what I was missing. So I was just counting and I couldn't get that one.
Yeah. True. Correct,
That clarifies.
Yeah.
And the second environment, when we run the second environment with 2 server accounts, 2 servers, it actually deploy the entire resources, entire 11 resources, which is same as like dev in the after deploying the 2 servers, it will be the same as like dev. So dev and QA currently will have 11 resources. So for the demo, next command will be Terraform.
Can have we shown the environment in portal?
Yeah.
QA?
Yeah.
Okay, we have done the right. Okay.
We can also verify all the things are almost same as like the one QA by checking the extension. Extension is the last resource deployed in the Terraform. So extension is working fine or not. So it's almost working fine. So we can verify that all the things are working either from verifying from the portal or from here itself. We can see the status of resources deployed in the cloud. So now I am going to destroy the QA environment. Actually, destroy will be applicable in a project. Say an example, if you need to have a LNP environment which only need to deploy or only need to run on once in a month, or when a performance test is needed for the application, only that time we need to spin it up. And once the performance testing is completed, we need to destroy it. So in that scenario, or in another scenario, if your organization want a seasonal product, say example tax seasonal product or any other seasonal kind of product, we can spin it up in the season time, and in the off season time we can easily destroy the environment. Even when a new requirement come or the same requirement come, we can again spin it up with the same code. So destroy is also important in the Terraform side. And here in the destroy, you can see this symbol, that means a red color symbol, just showing that, indicating that these resources will get destroyed. These resources, Azure virtual machine or virtual network, will get destroyed with respect to the plan. So all the resources, all the 11 resources will going to get destroyed according to the plan report.
And yeah, and one more point to add, like currently we shown like simple scenarios like creating and destruction, creation and destruction, and it will be like notified as symbolized as green plus and red minus. And we'll be having like in complex scenarios, we'll be like updating our existing resources, adding an OS disk to the VM, or maybe any changes to an existing environment. It will be denoted as it like yellow tilt on the plan. So we need to be real careful on what we are going to do, and that will make the changes to the. But the Terraform actually provides us an option to view the changes even before applying that to the environment. So that gives us an opportunity to evaluate it. So just thought of mentioning that. So the destruction is in progress.
So Sunil, if you want to just destroy, what do you say, a selected number of VMs,
yeah,
does it have a provision to do that one? So suppose I created a baseline and I wanted the VMs to be destroyed as per the baseline.
That is possible. Actually, what we can currently we created VMs based on count, so we can reduce it. So it will delete one thing, but usually we'll not go with in this way. Actually, we might, if we need multiple things, like we'll be having separate resources created in the module files. It's like the Terraform files. So we can just delete that resource from the Terraform file and plan it. So that specific resource will be deleted. So if we have a data disk associated to, suppose just in case, data disk associated to, instead of OS disk, if we have a data disk associated to a VM, and at some point of time we had decided to remove it, just remove that code snippet from that and save it, plan it again, we will see that update in the existing resource. Similarly, you created a VM separately using a resource module. If you are removing it out of the like say Terraform file and save it and plan it again, those VMs or how we provisioned it, it will be removed.
Yeah, just one more point. This is Midhun. One more point to add is Syam, you're mute. Okay. So I mean,
I think, yeah.
Yeah, Midhun, you're audible.
Hello. Am I audible?
Yeah.
So the point I want to mention is we are dealing only with the Terraform, and one caution is Terraform will do the management, either delete or update or create. Those things will be done for those resources which is created by this Terraform. If we have an environment and we have created few items manually, those resources will not be get touched by the Terraform.
Yeah, that was my point.
Yeah, and let's say in your example, and if say in I'll see in your scenario, I'll be seeing in a different way. Let's say I'll be usually declaring a variable, just say high, low, and medium. And in the high mode, I'll be placing 5 VMs on it, and in the low mode, I'll be placing 2 VMs, and in the medium mode, I'll be placing 3 VMs. Let's say, just for an example sake. And when we variabilize it, and we will be creating VMs according to that size with that variable, I'll be assigning that number of VMs will be associated. And if say I have a short code that from starting from this day or a particular day, and I will be in a peak time, and I'll be configuring this state as a high or something like that, and run the script. And as Sunil said, I will be planning and applying that infra changes to my cloud environment, and simply seeing that VM will be up and running. That's it. That's the way I'll be doing it.
So Midhun, my question is that, see, suppose I have created I got some Windows 2008 servers in my environment. I have moved them to cloud.
Okay.
Using migration process, I have moved it to cloud, and now I have adopted Terraform at a later date.
Okay.
Right?
Yeah.
Now, when I set the baseline, I find that this 2008 is end of support life. So I have created other VMs to replace these things, and I want to get rid of the old ones.
Okay.
So would that be possible by creating a baseline and saying that, see, this is the list? Or
the resources, as I mentioned, the resources which is already there in the cloud will not be get touched with the Terraform. Those resources which is created by Terraform will be manageable by the Terraform.
So is there any way we can add that to the list, or we can enroll them to that Terraform one? Means, yeah.
One option, import option, Terraform import option is available.
Mm-hmm.
If it is the provider is supporting the import option, we can import the existing metadata of resource to the Terraform state file. Then it will be considered as the resource which is created through Terraform. So it is possible, but the always it is not possible. That means in all time it will not be possible. Sometime it will go through some conflicts.
Yeah, Syam and Sunil, actually we can park this question for the last, and
yes, absolutely.
Let us complete this session, and we are there actually. We'll be there in the question session soon. But yeah, let us complete it.
Yeah. Thanks, Sunil.
Yeah. So Terraform destroy is completed. It entirely destroy my QA environment, and now only I have the dev. Even though my entire QA code is available next time, if I want to spin up the QA environment, then I can again do the Terraform init and apply, or init and apply to deploy the QA environment. Once again, I'm coming to coming to my dev environment, and let's see. I'm going to remove one server, as you stated in the question.
Yep.
I am removing one server, and just checking what will be the Terraform plan output for your question by removing a server from removing a resource from the development environment. Currently we have 2 servers. I just removing one server VM2 with all its dependencies. So how it will be look like? So you can see previously it applied 4 resources need to get added when we created a new VM. Now you can see four resources will get destroyed according to removing one server count. Normally we can use either server count or we can clone the same virtual machine file once again for creating another server. So it will not touch, basically it will not touch the existing resource. So here we can see the virtual machine with index name 1 will get destroyed. Index name, no, it's 1, not the server name. Server name is 2 will get destroyed.
And we can see the name and everything in the details actually. Yeah. VM2.
Yeah. VM2 will get destroyed. So the symbol itself saying that it get destroyed, and in writing also we can see it get destroyed.
The VM in the index 1 will be destroyed, and in the index 0 we have VM1. So if you need to have granular control on which VM to be deleted, as Syam was mentioning, we can copy the virtual machine script, and instead of using server count and using it, and we can just, if you need to delete the VM1 first before 2, you can just delete that file or comment that out, and then you will be able to remove that one. So you have control over it.
Yeah.
Yeah.
Okay.
You can try. Yeah, you can try. You can try this and.
Okay, I'm going with confirmation S, and it will destroy one VM. Last deployed VM, because of we gone through the iteration model, server count iteration, so it will destroy the last VM. And let it destroy. Meanwhile, we will go through a couple of variable files or auto.tf files. So here in this scenario, I just cloned the entire files of dev environment to create a QA environment. We remove the dependency, even though we need to clone or we need to copy resource group, virtual network, subnet, entire thing again for creating my QA environment. So I need to do for the prod. Do I need to do for the LNP or prod for doing the same things? Actually not. In most of the companies, most of the organization, they are maintaining different environment specific auto.tf vars file. That means automatically it will detect what are the environments available, and it will take the required specific variable details according to each environment. Here I am saying dev environment with single VM and my QA environment with 2 VMs. So the Terraform code will only we need to have a single Terraform code, and will control all the environments with these variable files. So auto.tfvars or TFVars, which already discussed by Midhun, I just want to mention over here that TFVars is very powerful when we are in multiple organizations. They are controlling their infrastructure or environment using auto.tfvars. So it's destroy session, it's getting destroyed. So one more additional point I would like to mention. So it's destroy is completed, and we can see server when we are refreshing it, virtual machine 2 is destroyed. So we only have virtual machine 1. So one more point I would like to add is the advanced version of how we can use the Terraform advanced version. So actually Terraform is an open source free version, and the integrations are available for Terraform. As part of DevOps introduction, there are many integrations we can do with Terraform. Since we are working with multiple group people or with a group of Terraform developers, we can integrate it with Git for a centralized repository, and as a free CI/CD pipeline, creating a CI/CD pipeline, we can use Jenkins, or if it is a paid version, we can use Azure DevOps for doing the DevOps integration for the Terraform. And in enterprise model, we can integrate it with Terraform Enterprise, which is the enterprise edition of Terraform. That will be covered by Midhun. So once again, thanks for watching the demo, and handing over to you, Midhun.
Thank you. Thank you, Chap. Am I audible?
Yeah, you're audible.
Could you please change the slide? Let it be.
Yeah.
Okay. So I'm seeing echo. Could you please be on mute? Okay. So as Syam was mentioning, we have a Terraform advanced version. With a generic Terraform resource script, still we need to write intensive level of coding. And say let's talk about few of the scenarios. What if organization require an organization higher level standards or policy need to be involved, or need to be introduced into the cloud based on their environment, and TFE have that. TFE is the solution for it, and it gives the enterprise or the company or the organization a provision to register their own create custom modules and register into Terraform. And the application team will be actually writing minimum code, fair minimum code, when compared to the regular used modules, just like the example shown in the demo. So in here, the application team will be putting their resource code, which will be kept in Azure Git in our scenario. And the module registry, we will be keeping all our Terraform related custom modules will be generated, and it will be kept in their portal itself. And we will be pushing those changes, infrascript changes, by an automatic trigger pipeline, and pushes those changes to the Terraform application workspace. And the app, as we see in the demo, we will be having an init apply plan and apply. Those actions will be managed in the portal itself, and the portal will be starting the init, and it will expose the plan, and we will be able to predict the changes, and we can have an approval on the changes what we have, and we can decide it and go for an apply. And in our case it is Azure, and we will be those changes will be reflected in the cloud. So it is the advanced version that is also possible for it. Okay. And
Yeah, one point. One point to add over here. In this case, in the Terraform Enterprise version, Terraform provides a portal, like web portal, where we will be able to visualize. Like currently, we are seeing it in the console, right? So in the portal, actually, we can see the init and plan going on, and what changes we need to do. So plan will be there officially, and then before apply, we need to provide a confirmation. All those, instead of doing it in command line, we can do that on a web portal. And application workspace. So each environment for an application can have a separate workspace, and all the states of that specific workspace, like environment, will be kept in that workspace and managed by Terraform. So, and this module, Midhun already covered that. The module registry will be having enterprises can create custom resources with their policy applied to it. Take the case of a storage account, we can deny, we can avoid the application teams creating public storage accounts. So we can make sure that by policy it is restricted, and they will not be able to. So it will be an integral part of an enterprise to make sure that the policies are applied across the enterprise, and make sure that they are under the policy umbrella of the enterprise. So just thought of mentioning that. And going forward, like since DevOps is coming into picture, right? So the gap between the cloud team and the development team and engineers are getting narrowed down day by day. So at some point of time, the cloud, all the cloud infra will be created and managed by the application or development project team itself. So it is really necessary for an enterprise to keep the module registry and create modules and make it updated based on their policy. Just thought of adding it. Yeah.
Yeah. Thank you, Sunil.
Yeah. Yeah.
Sunil, just a question, Pravit here.
Yeah.
Is this Terraform Enterprise Edition also supporting hybrid cloud?
Yes, it is.
Yeah.
Okay.
Yeah. Let me take a moment to cast my vote of thanks. thanking Prathidhwani and our friends over there to conduct this session to the entire Technopark and to the external audience and giving us a chance to present here. And then thanking you all, the wonderful audience, for being patient and curious throughout the session. And also thanking the management and HR of our beloved firm HNA Block for allowing us to present in an external session and also providing us the necessary infrastructure and opportunity to support to learn any new technology such as Terraform and excel in it. So we think this would be a great career and business opportunity for all. Like, for example, anyone who is new to infrastructure as a code can learn it. Cloud members who is using manual code now can start using IaC tools. Cloud members who use Terraform now can think of upgrading to Terraform Enterprise. Managers or people leaders can think of start using IaC tools in their project to boost the productivity and thus by saving cost. So I think everyone can benefit from this. So thanking you all again. It was a real nice experience to talk to you all. Thank you. And we can go to the Q&A. Yeah.
Any questions from anybody?
Yeah, Pravit here again. Actually, I have few questions noted down. I'm not sure if that is very simple ones, but I just wanted to clarify. Like, do we have this CLI version of Terraform available in Google Cloud and IBM Cloud also, or only for Azure?
It's available for all the most of the providers which are supported by Terraform. So Google and Google, AWS, Kubernetes, IBM are also supported by Terraform.
Okay. Okay.
These are the providers.
Okay. Thanks. And another one. Is there an option, like, for example, when we run this Terraform code, like the application team who is creating those resources and running during the plan phase, is there an option that we can also see the billing, like how much cost that would be adding to the current, cloud?
Yes. So when we are running through the TFE portal, there is a Sentinel policy as well as cost estimation will be shown in the portal itself, so we can identify how much cost it will be for creating a planned resource, and if it is within our limited budget, then we can go ahead and do that. Otherwise, it will get we can discard the plan.
Okay, thanks for that update. I just wanted to confirm if that option is there. Thank you.
Yeah, we have a query from Lijo Thomas who was asking, how can we spin up a new environment with like pro.auto.tfs instead of calling and cloning an existing folder of one of the environment. Like as I think this has been already covered by Syam, but just to add like just to answer that query, like we need to generate or write our scripts so generic and so generic in a variabilized manner, and we can we'll be declaring the variables in the variable file, variable.tf file, and then at a later time we can put the default values to the variable file in the variables while we declare it at the time itself. And if you need to make any customizations, right, like the images that being then the size of the OS disk or maybe anything, be it anything, we can variabilize. We can provide the values to the auto.tfvars file and just provide that along with the other TF files to Terraform. Terraform will take care of that. Like they'll be overriding the variables, the default values in that variable.tf file and provide these values. And then if you are providing a standard value that is supported by the provider, it will be created accordingly.
Yeah. Another point I want to say is while declaring the variable itself, Terraform allows us to give a validation kind of thing, so that if the value we have defined or given will be validated while we are actually doing a planning, just like restriction kind of thing. Let's say I have a VM where I be a number as a variable, and I can put a restriction that not more than 10 VMs need to be deployed at any cost. So those kind of restrictions is also possible in Terraform variables. Just thought of adding it.
Yeah.
Any more questions, Rajat?
Pravit here again. I think I just have
Okay.
one more query. Like, see, as you said, there are, in manual we do have mistakes. It can also happen when we use Terraform. Like, for example, while running the Terraform, as you see, like you were in DB, and then Sunil asked you to go to QA before running the init. So something like this happens. For example, if I'm already running an infrastructure already with the Terraform, and unknowingly I'm in the directory which is actually or the old one which has been running from 10 days, and I'm having a lot of updates done. If I run the plan again on the same Terraform, same directory, would that replace the old one with the fresh one, or will it do nothing?
So
Yeah, it depends on what you have done on the code. So if you mistakenly done the changes to the dev folder, and you made the changes to the current resource files and run the plan, right? Plan would not do anything. Actually, it will be checking the desired state with the current state and showing you, the plan phase will show you the changes that are going to happen. Okay, so based on that, actually at that time you will be able to understand that actually, okay, I made a mistake. This is not the environment. Actually, you'll be seeing everything, like all in and out details of a resource that is getting changed. If it is getting updated or deleted or anything, so you can just revert those changes, and or maybe neglect that and do not apply it. Just step back and do the changes on the other environment. And in Terraform, right, in Terraform Enterprise, it would be more easy actually for each environment. We can keep separate workspaces, and we'll be seeing the run specific to that environment only on that workspace. So the state and everything will be kept very really. It is visually it can be visually seen.
Okay.
Yeah.
Thanks.
adding to Sunil's point, actually the Terraform coding is like documenting your infrastructure. You can see if you a person who knows the Terraform, they can easily identify what are the infrastructure you or the previous engineer or the previous organization configured in their environment. So we can see a resource group will be created, virtual network will be created with these parameters. So basically it's a documentation where we can easily understand what are the resources implemented till now or going to be get implemented with respect to our plan, and what are the things already get implemented. That means the current state of what we implemented is we can see from the Terraform state file. So we can see all the variable or all the details which is already implemented through the last run. So from Terraform state file itself, it will verify is there any changes or any additional things what we missed from the configuration. So it will show in the plan itself. So you can identify either from plan or verifying from TF state file, you can identify the changes, or even going through the written code or the documentation. This we can also consider as a documentation of our infrastructure. Going through this file also, we can able to identify what are the changes going to get applied.
Okay, thanks. So actually that also applies like when we have this variables vars file, the TF vars which has been created for dev and QA separately. So we have to create that for each environment separately when we like copy the directory, right? So you copied the dev DB to QA, and then just initialize the QA. So will that create the vars file automatically while initializing, or we have to provide that as an input?
Okay, there is two things actually. In real time, we'll not be copying the folders. We'll be just keeping the generalized resource structure and providing the variables like TFR variables. Okay. So yeah, that is the only thing. And so in the only thing that we need to make sure that before we do the plan or apply, we'll be providing the correct environment TFR files to the Terraform. So it will be in the variable files. So we need to do a scripting to just copy the TFR file to the result, like the final folder, and do that. So maybe a temporary folder and do the stuff. And like in DevOps, if you're coming to Azure DevOps and all, we can actually do the stages in the scripts to copy these files to the result, the target folder, and Terraform do the result, remaining thing for us for that environment.
Okay. Thanks, Sunil and Midhun. I think that really helped me out. Thanks a lot.
Yeah, thanks, Prathid, for the question. Nice questions.
Yeah.
One
Thank
more
you.
question. One more question from. I think testing part we can do. We can include testing part in the Terraform. Yes. One TerraTest option. TerraTest is a module, or TerraTest option is available for testing the Terraform code. We can also integrate TerraTest with our code to identify or do the unit test of our Terraform codes.
And okay, and we have one more query from Jobin Storm. Can we define who we can access the resource from Terraform itself? I would say it is a responsibility of the provider. Take the example of Azure. So if you are creating a specific resource in a development subscription or QA subscription or anything, or in that specific resource group, the access to the that specific resource group will be managed by separate access policies by using RBAC. And normally it will be used done using AD groups. Access to specific AD groups will get access to that. So in this case, actually, we are the owners, and we are the owners for the subscription. We'll be able to see everything, but that will not be the normal case. In an enterprise, a specific project will be having a resource group associated to for their one of their environment, and only destined members will be able to access that. And we'll be having an access policy set for the enterprise, right? So maybe adding we'll be having separate user roles like reader access, contributor access, owner access, and everything. So based on the access level, users will be able to do that. This part is actually more towards provisioning or creating or provisioning the cloud resources. I think Jobins, I have answered you. Jobins, right? Yeah, Jobins, Tom. Yeah, correct.
And there is another question, I believe.
So on the last question, adding to Sunil's point, if it is for the Terraform access also, we need to define the access role in the Azure DevOps or the Git who can access the code and run it from the DevOps pipeline. So that is also depends on the access policy we define for our organization or the member.
Get the Terraform code and existing. Is there any way to get the Terraform code for an existing Azure resource created manually? Okay.
I think, yeah, it is already covered in our previous. Yes, it is possible, but it's if and only if the provider is allowing us to do that.
The import option that you were mentioning,
Yeah,
right?
yes,
Syam
yes.
already mentioned that. Yeah, correct.
Yeah.
For that, we need to create the same kind of code and do the import command for importing the existing resource with respect to the resource ID. From the properties itself, we can get the resource ID. We can import the state of this resource to our Terraform state file. The state file. So the state file will identify it is created through Terraform, even though it is not created through Terraform.
Hello, Syam. One more doubt.
Yeah.
So can we use the same scripts for if we want to create the same resources in any other cloud services like AWS or anything? Just need to change the provider name only, right?
No, actually, the entire resource when we are so anyway, provider from the main.tf entire thing need to change. First of all, the provider version, everything need to change. Second thing, these types are only specific for Azure, not for AWS. So Azure, say an example, I need to create a virtual machine in Azure. I need to mention it as Azure virtual machine, and in AWS, it will become EC2 instance. So the syntax and the parameters will be almost the syntax level. It is fine. The Terraform syntax will be same for Azure as well as any provider. It will be the syntax will be same, but the parameters what we are declaring from here to here will be different for each environment or each provider. So here we are not mentioning any EC2 instance here only or any other Google Compute Engine. It will be different keyword for Google Compute Engine So only the syntax will be same for all the provider. All other remaining parameters will be different.
Okay,
So
okay, got
we cannot use the same code
Yeah, yeah.
running in AWS and Azure. But one thing we can do, if you are using the module, say example, I need to create a VM. So I write the code for Azure and AWS, and using the logic, that means if condition, if I am giving dev as a variable, then if I am giving AWS as a variable, then it will deploy in AWS. If I am giving a variable as Azure, then it will deploy the Azure. That can be accomplished through module, defining through the module.
Got it. Okay.
That's why it's saying multi-cloud environment deployments we can accomplish through Terraform.
Okay, got it. So one more doubt, Syam. You are specifying like we can use Kubernetes also with the Terraform. So Kubernetes already have some scripting and automated resource creation and all. So what's the advantage Terraform brings in Kubernetes? Any idea?
So basically, whatever we are creating through, so there are package managers are there like Helm, and other package managers are available for YAML file. So controlling those files through Terraform is possible. Yeah.
Okay. Yeah, thanks.
Yeah. It's for basically for the native Kubernetes, not the provider specific like Azure Kubernetes or Elastic Kubernetes. We can control it through the provider itself, Azure or AWS. Here, the Terraform native Kubernetes itself will be supported in the Terraform.
Okay. Yeah. Thanks.
Yeah.
We have passed 10 minutes already. I know this topic is really vast, but we'll have to wind up at some time.
Yeah.
If we still have questions, you can reach out directly. Maybe we can provide contact for the trainers.
So do we have a forum where we can post the questions?
You can post.
Actually, we can provide the like presentation to like Rajit or the team, and they can share you the details. And the appendix is having the source code and all the other details, and you can refer the environment setup. And in case anything is required, we'll be reachable. And if anything is that need to be channelized via Prathidhwani, that is also fine.
Yeah, you can reach out to me, or maybe you can get the trainers contact as well and reach out them directly. They are really reachable.
Yeah.
Okay, so
Thank you.
yeah, thanks Midhun, Syam and Sunil for that wonderful session. Thanks Midhun for coordinating it. I put a link for giving your feedback on the session. Just 1 minute, like spend 1 minute and give your feedback, and you guys can help us with suggesting new topics like this, which you think we'll have to take up in coming sessions. And if you are interested in taking sessions, do let us know. And as I said in the beginning, like we have multiple forums like women's forum, arts forum, sports forum, this technical things, travel forum, film club, literature club, anything you are interested in, please reach out to us. If you are willing to contribute something, or if you are willing to spend some time, half an hour, please reach out to us. And thank you all for joining.
Okay. And Rajit, actually, one more thing. Actually, if you get all like responses from the team on this survey, right? Please share that to us, like just to see how it was accepted, and like if we need to make any changes to the mode we do, right? We can do that as well. So any like open feedbacks are really welcome. Yeah, thanks, and thank you all.
Yeah, sure. Yeah, we'll be passing.
Thanks for the wonderful presentation.
Yeah. Thank you all for joining.
Thank you. Thank you.
Thank you all.
Thank
Bye.
you.
all.
Bye bye.
Thank you.